Okay, cool. Hi everyone, I'm Andrew. As I said, I'm a software engineer on the Atlassian design system team. There are my handles, not that I really use them. And on the design system team, we've been working on a lot of really exciting things recently. And I'm going to be talking about some things I've learned while working on those. So we've been working on dark mode in particular. Dark mode is a feature that launched recently in Jira and Confluence and Trello and a few other places. It was a huge effort to migrate a large amount of the code base in all these different products, moving to this new system called design tokens. It involved diving a lot into color, and in particular, we dived into a lot of CSS and JavaScript, of course. And I think it was a really good lesson, actually, in getting the right balance between CSS and JavaScript. I think before, when you were doing dark theming, you really had to lean a lot into JavaScript, maybe using React context or something like that, and a React app to switch, or having some data attributes and switching some styles. Plenty of ways to do it. We were using a React context-based approach, and we ended up switching to using CSS variables. The platform was ready for us. And because we were ready for the platform, we ended up having a much easier time with our migration, and our solution ended up standing up to all the various technical hurdles that we bumped into. Why am I talking about this? Well, because we built dark theme, we then got into the next step, which is what can you do when you have the ability to make all kinds of wild and wacky themes? You can't just make light theme and dark theme. You could do all kinds of things. So we got into this idea of what if you could make custom branded color themes? Again, not a brand new idea. If you've used Material View, you might have seen this on Android. There's a lot of design systems who have tried this kind of thing. We were looking into this idea of, if you can get the Atlassian design system and all of its different buttons and dialogues and so on, and just switch the brand color around, pretty neat. You could do some cool experiences with that. And in this experience, we ended up working with designers on a system. And this system required diving in a bit into color theory, and that's what I'm going to be talking about today. So we started off with a custom brand color from a customer, this purple color. We kind of, from a design perspective, what you're generally doing is you're dividing that up into a ramp of 10 or however many different colors you need, from lightest to darkest. And then the designers can choose from that. In our case, we have a bunch of design tokens helpfully named for people to be able to start building their UI. Great. This is a cool system. The complex bit is here. How do you generate these? And then how do you choose these? There's a bunch of logic in there to get that working. And that's where we were leaning into JavaScript. So for this prototype, we ended up using JavaScript. We used Leonardo for our designers. It's a tool made by some folks in Adobe. It's a really cool library. It lets you kind of like fiddle around and generate these palettes. And you can put in all kinds of requirements like certain WCAG contrast ratios, you can basically choose whatever color system you want. You get into all this terminology and stuff that's very strange, which I had to dive into. And we ended up shipping it using Material Color Utils, which is a library that Google shipped as part of the Material Color system, which also allowed to do the same thing, but it was a little bit more performant, and we were using it on the JavaScript side. So JavaScript, lots of JavaScript talk here. But I got a bit curious about, well, JavaScript's great, but it's always good to use a little bit less JavaScript, right? What if we can avoid some of these large libraries? What if we can lean into CSS? And you hear about this. There's all these new color features coming to CSS. I'm sure you've seen some blog posts about this, about the new color features coming to CSS. Anyone heard or anyone seen any talks talking about this? There's some great blogs online going through some of the proposed features. Here's a smattering of them. You've got new color spaces. Anyone excited for Adobe 98 RGB and Rec 2020 and HWB and LCH and Lab and OKLab? What's OKLab? Other features in syntax, there's color and color mix and contrast color and all kinds of things. So these are cool. They're interesting. What on earth are they? It's a lot. And so my goal for this sort of talk is, and yes, it's a little bit away from JavaScript. It's more towards the web in general and understanding these systems. But it's an interesting talk, I think, because it goes into, I'm going into the intro to color formats, gamuts, and spaces, and teaching you, hopefully, or at least explaining what I've found out so far about color formats, gamuts, and spaces, and the color systems underneath a lot of the experiences that end up being built on the web. And then I'll be diving into some of those new features that are coming in CSS, so color spaces and utilities. And then I'll be talking about using these features in practice. So let's dive in. Here's a quick, hopefully, intro to color theory. So to start off, the concept of color. What is color? Color is a construct that we made up to describe what we see with our eyes. In particular, with the rods and cones that we have in there. So we have three, I've forgotten if it's rods or cones, I should know this. but we have 3 of them. They detect the different cones. Nice. Thank you. Yeah. So we have 3 cones. They have different intensities of wavelength that they detect. If you put them together, you can end up with a colorful image. If you notice, that matches up with the pixels that are displayed on a modern laptop. It's for a reason. And scientists were very clever, and they tried to work out and map out, well, what kind of colors can the human eye see based on these rods and cones? Getting mixed up. So based on these cones, what colors can the human eye see? There's a standard called CIE 1931. Yes, it's from from quite a long time ago. And they got a bunch of participants. I think it was like 20. I think it was like 10 participants in one study and 7 in another. It was a surprisingly small number of people. And they got them to look at a bunch of colors and detect what are the boundaries of what humans can perceive. And then they mapped it out into this lovely chart here. Obviously, this isn't every color that exists. There's darker and lighter shades and things like that. But it's kind of a mapping of generally the space of what humans can perceive. Of course, this is different for everyone. Some people can see more colors. I think there are people who have extra capability to see more colors. Some people can see into different frequencies. Some people are colorblind and they see this same spectrum in a different way. So of course, it all is very subjective, but there's some standardized lineup of basically what humans can perceive. And this is turned into different color spaces. There's 2 here I've listed here called a P3 display and sRGB, and I'll get into these. But a color space is effectively an organization of colors. It's getting an idea of these things we see with our eyes and turning it into some kind of grouping, some kind of selection. It's like a subset of colors that exist. And a really great tool, is this mic on? Don't want to, if I'm getting doubled up, then let me know. A great tool to look into this is the color sync utility on Mac. I'm sure there are others as well. But I'll show you this real quick because it's a cool little tool and it's available for anyone to play around with if you've got a Mac. So you can click into this tool and you can click on a color space and you can see it in 3D. How cool is that? But more interestingly, you can look at this color space. It's kind of mapped in 3-dimensional space, and you can compare it to other color spaces. So let's dive into this other one, Display P3. It's a bit bigger, contains more colors. Let's go to Adobe RGB. It's slightly different. Has more greens, I think. That's some more interesting ones. I said it was an organization of colors. It doesn't have to be the full spectrum or close to the full spectrum. Here's black and white. It's a 1-dimensional color space. It's just going from gray to less gray. Here's blue tones. I don't know what this one is. It's in here, though. Here's some sepia tones. And another interesting one, this is a discrete sort of color space, is the web-safe colors. This is a numbered set, a named set of colors that you can use in the web. We don't really use anymore, as I understand. But here they are. They are numbered out, and they are placed in the same spectrum as the others. But in this case, they're discrete points. So talking about all of this, what are some examples of these color spaces? We've got sRGB, which is, it's hard to say legacy standard, it's just the standard, but it's what's on most computer displays. There's P3, which is wider gamut. You'll generally hear fancy monitors saying, we've got 93% coverage of the P3 color space, which means that their gamut, so what they can display, isn't quite at the P3 color space, but it's close enough that it's certainly better than sRGB, so it's something to market. Rec 2020 is a broadcast format that was introduced in 2020. It's used for HDR content. So we've heard about Dolby Vision and what is it, HDR10 and all these different formats. They all ultimately are mapped into the Rec 2020 format. That's a standard of what can be encapsulated in these broadcast formats. Until recently, browsers have only supported sRGB, except mostly. This is an interesting little side discussion. So I was looking into this. You have 2 transparent colors. You put them together. What's this color? Oh, yeah, what's that color? So when you blend colors together, you're doing something called generally normal blending to combine those 2 colors together. You can map this out in JavaScript. And if you play around with that, oh, I know which way's forward. If you do that, then you can kind of in JavaScript, I've just done a calculation of what a color can be. And then this one, I've gotten 2 divs and put them on top of each other. And I was like, can I do the math? From an accessibility perspective for a website, can you math out how 2 colors will combine and do that math ahead of time at build time and calculate, do all these various interesting things? You can see they look the same until they don't. This is on a P3 monitor. I found this, I was coming home and I had my laptop plugged in, I was on the train, and suddenly the colors looked different. It turns out on a P3 display, Chrome and Safari specifically will do the normal blending in whatever color space the monitor's in, not in the color space of the web, which is generally sRGB, because it's undefined behavior. I think this is probably going to get worked out in standards at some point, but that's where we're at right now. So just a side note on all this is kind of fuzzy at times because it hasn't really been defined. So color formats. Let's talk about those. So, we've talked about the color spaces, but how do you choose a color from them? Well, that's where color formats come in. Color formats are some kind of model for representing colors as numbers. They're generally a tuple of 3 values. Hex is basically a tuple if you split it out into groups of 2. So RGB and hex is the most common one. This is a great visualization from Josh Kamei. It's a really good blog post that kind of runs through and explains these concepts. If you want to do more reading, please go to this link. It really explains things really well. They have the interactive illustrations. But you can see here that you're adjusting basically just how bright the pixels are. It's very much mapped to hardware. It's not mapped to the human brain. It's just how bright should pixel be. And again, that's not tuned to our eyes. It's just how bright green should be, or blue should be, or red should be on the screen, how bright the pixels. So that's one model. Another model, you can kind of think about it as a cube, where red, green, and blue are different dimensions. Choosing one from a cube with like 256 colors in each dimension. Another color format is HSL, which you might have used. This is a more human-readable variant of that's also in the sRGB color space generally. And you can choose a color here based on saturation and lightness, which is more intuitive. Generally, you might want to keep the same lightness of a color and just change the saturation and get 2 colors that are analogous. This is kind of useful. But this is still in generally sRGB, and there are limitations which I'll talk about soon. And you can think about this as a cylinder of color. It's just a different math model. So saturation is going out towards the edges. Hue is going around in an orbit. Value is, I think this is actually HSV's model, not HSL, but same general concept. You're changing different dimensions. So this is what we've got right now on the web. We've got named colors, hex colors, RGB, HSL. We've got the sRGB color space. We've got new stuff, and I'll be talking about that now. So what's coming new? We've got these color utilities. So to start off, color. Color is a keyword that lets you specify colors in much wider gamuts than were previously available. So you can see here that we can specify color in display P3 111. What's that format? It's a coordinate format for display P3. It's not one of the formats we talked about before. It's a limitation of this particular feature. But you can see here that you can choose a color in display P3, which the web couldn't do before. Neat. The outcome of this is new colors have just dropped, or they dropped a little while back. So you can see here, this is the sRGB sort of boundaries, and you can see how much sort of more color you get with P3 by comparison. Obviously, this is simulated. I don't know what this display is. This display could be an sRGB monitor, in which case it's all being scaled down, but you get the idea. Well, here's a good gradient example of how much more vibrant colors you can get. So scan this QR code and check it out. This is a blog from the WebKit folks. They run through a bunch of sample images and sample colors. You can see a redder red than you've ever seen before on a web page, unless you've gone to, I think, Panic for the Playdate. They had like a bright yellow background that was in P3, and it really popped out because you'd never seen that color on a web browser before. So it's pretty neat. Give it a go. So color has been supported in all major browsers since July 4th. Excellent. It's only supported, of course, on displays that have a color gamut that includes the larger color space. So that's all newer iPhones, newer Macs, newer Windows and Android devices, higher-end monitors. Really depends. Of course, you can't necessarily rely on a customer or some user actually having a device that matches. At Atlassian, for example, we have plenty of customers who are on enterprise machines and might have a bog standard monitor from however long ago, 1080p, not necessarily color-tuned. You can't control any of this. So. But for users who can benefit, it's a cool feature. Another thing that's coming soon is custom color spaces. I talked about them being groupings of colors. CMYK is used for printing, right? You've got a printer. It can print with different pigments. Those pigments are more limited than what a computer monitor can emit. So you can tune a custom CMYK model that represents exactly what your printer can output. And you can put that into the web and maybe be able to have a website that can display with the exact right colors that allow you to print perfectly on your printer. So that's kind of handy. What's next? So I've talked about, I mentioned lab and LCH. So lab is like a new perceptually uniform color space. It includes basically all the colors we can see and more. There's no limits to the numbers you can put in it. There's no boundaries. And I'll get into that. But they also come with LCH, a nicer color format for displaying the same thing. So you can see here you've got hue, chroma, and lightness. You can kind of see chroma is like brightness, and lightness is light to black, and chroma is your sort of saturation. This is in a bounding box, but of course you can actually go chroma. You can keep going chroma all the way out into colors that we can't even perceive. They're called imaginary colors because the human eye can't perceive them, but they are technically mathematically existent. They are in this model for whatever reason. So they're different coordinate systems. You can basically ignore lab. It's like dimension A and B are green to magenta and yellow to blue. It's like an X and Y axis. Not very useful in day-to-day. Chroma and hue are much more useful metrics, particularly hue, because of course you can rotate it around and get different colors with the same lightness and chroma. So what does this mean? Perceptually uniform means that lightness will match your human perception. So here's HSL, again mapped to RGB based on pixel brightness, not based on your human perception. The same brightness value, 50%, looks much lighter for yellow and much darker for blue. It's because of the sensitivity of our eyeballs. LCH, meanwhile, has been tuned to this. You can see that for the same 55% luminosity, you end up, or lightness, you end up with fairly similar colors. This is important when doing gradients. So with a gradient, there's now a new feature called hue interpolation, where you can get a linear gradient and specify what color space it should be calculated in. And if you do it in OKLCH, for example, then you end up with this more, I guess, standard gradient that looks a bit more like colors being mixed together rather than this bright streak of yellow in the middle of HSL or this dark smear in the middle of sRGB. There's plenty of these around. There's plenty of options to choose from. OKLCH is not always the best one, by the way. To demonstrate this similarity, if you go grayscale, you can see it's perfectly uniform. How nice is that? So I mentioned imaginary colors. Perceptual models are wholly. So this is a chart of colors that can exist in LCH that also exist in sRGB. And you can see for lightness and for hue, on this chart, you can get a single lightness value in chroma and go across, and you'll hit patches where you just can't, the color doesn't exist in sRGB. You just hit a place in space that doesn't exist on that three-dimensional object that represents your HSL color or your RGB color space, which is kind of annoying. So you kind of rely on the browser to resolve these. I also mentioned, well, there's also OKLab and OKLCH. What are those? Well, they're bug fix. Lab was made quite a while ago, and it turns out there was a bug a bug in a color space where basically all the blues have this weird purple smear at certain points. It's just the way the math worked out. So they fixed that in OKLab, which is closer to what you'd expect. So generally, you should just use OKLab. There's a great blog post going into more details where these gradients are from. In summary, lots of different options. There's kind of a decision chart here of hard and easy to use and a bit buggy and up to date. Basically, just OKLCH if you just want to make human readable colors that are consistent across the spectra. It's probably the best one to choose from what I can see. So let's do an experiment. I wanted to generate those palettes. Currently, I'm doing it with JavaScript. Can I do it with CSS yet? So, can I generate, from 100, 200, 300, these different lightness values for a given ramp? Well, here's an example of how you could do it. You can set a CSS variable for chroma and hue, and then you can slot them in and just change the lightness value, and then maybe you get a nice ramp. That'd be pretty cool. Here's what you get. So this is what you get with JavaScript, beautiful JavaScript. And here's what you get with CSS. Unfortunately, not quite what I was looking for. Why is it getting all light blue? Why isn't it getting lighter? It should be like almost white by the X100. Why doesn't it look like this? And that's because the system has holes. So this is where we are for chroma and hue, and this is where sRGB is. The color doesn't exist, and the browser has to decide what to show. So we asked the browser, can we get some gamut mapping? This is the term used to define if your color's outside of the gamut, how you put it back into a color that's similar enough to our eyes. Browser says we've got gamut mapping at home. Beautiful. So this isn't what we want at all. This is why we're getting that light blue when we want a very, 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 almost like a whitish blue, because the gamut mapping isn't playing fair. It's basically doing some math where it just cuts off the top of the values, and that doesn't get you the colors that you expect. So, of course, JavaScript frameworks that are built around color do this for you because they're not, they have the constraints of the platform. They're able to do all kinds of custom logic, maybe at a performance cost, but they can certainly do it. So this is an example of atmos.style. It's a tool that lets you use LCH to create color palettes, and you can see that it nicely threads the needle and it adjusts the values until they sit in the right places. These gray areas are basically where the color doesn't exist, so it just avoids them for you with some nice logic. Final note, we're talking about lightness here. When you're doing accessible colors on the web, you need to make sure that you meet WCAG contrast ratios. That uses relative luminance, another L word, but it's not the same as lightness for LCH or for AHSL. They're all different terms. When you're generating colors, always make sure that you test them for accessibility and that you have enough safeguards and boundaries to make sure that things don't slip into an area where they'd be inaccessible, because you can't necessarily guarantee that just by looking at the colors. Here's an example of colors that might look like they have more contrast, but actually have worse contrast because of the way that the WCAG luminance system calculates these colors and whether they have enough contrast. As a final note, here's an example of the variance you get. This is like the relative luminance of 3 colors. They should all have the same brightness according to LCH, but the WCAG system gives one 3.3 and one 3.7. So there's a lot of variance that you have to be aware of. Okay, I've gotten past the color theory bit. I've gotten past the color spaces. Let's get into some exciting syntax and features. So what's new in CSS? Color utilities. Let's get into them. So the first one's color mix. Color mix lets you mix colors together. The name's pretty self-explanatory. So you can see here that we've got 2 colors mixed at 50% in OKLab. So you can specify the space in which you want to do the calculation. It's been supported in all major browsers since July 19th last year, so it's probably reaching the threshold where you can start playing around with it as long as you've not got enterprise customers who are on very old browsers. Here's an example of a use case for this. You want to create a hover and press state for a button. It's a bit of a boring case, but it's exciting to me. You can blend with black at 90% or 80% on hover and press states, and you can just get a nice interaction state without having to define extra colors and fiddle with all that. This can be very useful if you're managing a design system like we were, where like those ramps aren't very expressive and you bump into issues, you run out of colors. So being able to just generate them is pretty powerful. And this is the kind of stuff that you used to have to be able to do with less or some kind of preprocessor for CSS that would do the generation at build time. Now you can do it at runtime. And there's very exciting runtime-based experiences that you could do, certainly, where users are inputting colors and you're generating mixed colors as a result. Here's an experiment. Could we generate the saturated palettes I was talking about with color mix? Could we get a brand color and make a lighter version by mixing it with white? Kind of. It wasn't quite perfect when I tried it. You ended up with like things getting desaturated because you're blending with a color. You kind of blend out all the color. But I'll get into a more exciting way of managing this in a sec. Relative color syntax is where it's at, in my opinion. It's very exciting. So relative color syntax lets you derive new colors from existing ones and do math. So here's an example of a color. We're going from this color, 172B4D, and we're extracting out the L, the C, and the H. So we're converting it to LCH, extracting the parameters, and then we're doing stuff to them. So in this case, we're keeping L and H the same, but we're adding 15 to the chroma. Here's some examples of things you can do. You can darken, you can desaturate by setting the chroma to 0, or you can make things semi-transparent. This is a really good way to be able to get a color and make it transparent on the web, which was actually quite tricky to do before unless you just made the whole element transparent. It wasn't really easy to manipulate colors in that kind of way, or at least there were some trade-offs. So contrast color is another one. Contrast color lets you choose an accessible color from a provided set. This one is very far down the line, but it is exciting if you're dealing with these kind of WCAG contrast issues, which we certainly are having to work on at Atlassian. In this case, you can pick one color, your text, for example. It's probably not a good example because we're setting it as background, but you can choose a comparison color, which is the background, or you can set it as the foreground. You can say what standard you want to assess it at, and you can give it a list of colors. And what it'll do is it will check the first one, go, nope, that doesn't have enough contrast. Second one, yes, that has enough contrast against WCAG 2AA for background. And then check the third one, and it doesn't really matter what this one is. It picks the first one it finds, which means that you can give it a priority list of things that you want to be able to display. Worst case, if none of them work, it'll then check against white and black and choose which one it prefers. Finally, there's light-dark. Light-dark is a shortcut to light and dark theming. So if you don't want to deal with media queries and things like that, you just want to basically set what something should look like in light and dark mode, you can set the color, you can set the background color, and it'll all just work. So this works only in Firefox right now, but you can see a web page, I'm switching to dark mode. That's literally all the CSS that I used, and I've got a beautiful dark theme that just works. So what's the availability of all of these? When can you use them? Ready to use all of these things here. So color mix is probably the biggest syntax feature. Otherwise, it's these new color spaces and LCH. Coming soon is relative color syntax, which was in Safari and is now in Chrome as of, I think, a few months ago. I think it was maybe even recently. It was Chrome 120, which I think is the most recent, one of the most recent releases. And light dark syntax is only in Firefox, but it is in CSS Color 5, which is one of the newest standards, but it has been approved and it's been confirmed, and so browsers are starting to adopt it. Contrast color, between when I first wrote this talk and today, the spec changed and I had to redo the slide, so it's definitely not ready yet. It's coming soon. I think it might be in Chromium, but it's certainly in Safari, but it is by no means at a stage where you can really reliably use it. So worth keeping in mind. If you're interested in any of this stuff, I really recommend having a look at the CSS color specs. It's a whole standardization process. It goes really nerdy into all the details. You can look into them and see people discussing about how should we improve gamut mapping on the web? Hey, I found this more efficient algorithm for making browsers more efficient. People do all kinds of wild stuff. And it's quite cool to dive in. And of course, this is all on GitHub and other discussion forums. You can jump in and have your opinions. If you want or you have an idea for contrast color and how it could be improved, you can jump in and do that. It's certainly open. It's open to those kind of discussions. So, with that in mind, thank you for listening.